Example 7. A side of the triangle below has been extended to form an exterior angle of 125. Find the value of x. So in the next two examples, we're going to be dealing with what's called the exterior angle. In the first example, it's a little bit more complex because typically we'll work from the exterior angle and then find out what this angle is right here. In other words, we're going to have to do a step here to find out what x is. And so this will be a two-step in this one. In example number 8, this is really only one step because we should know that 159 and x, there's a special relationship. Okay, so here we go. This is the two-step one. So the first thing that I'd like to do is I'm going to use an arc, a red arc, to represent this obtuse angle of 125 and to work from the exterior to the interior, pardon me, of the triangle. I'm going to mark this as blue. And then because this is an unknown there, I'm going to go ahead and represent this unknown as y. Again, not using x because we already have x for another value. And then please notice that the blue angle and the red angle, they're actually adjacent to each other. And if we add them together, notice that red plus blue, that adds up to 180 degrees. In other words, those are a linear pair. They're a pair of angles that make a straight line which has a measure of 180. So my equation would simply be the blue angle, which is y, add the red angle, which is 125, and that has to be equal to 180 degrees. Then I'll use the subtraction property of equality, which is a fancy way for saying subtract 125 on both sides. On the left, this will cancel to 0, but y plus 0, well, that just simplifies to y. Then on the right side, 180 minus 125 leaves me with 55. So I'm going to go ahead and take this value of 55 and I'm going to substitute it for y right there. So bringing it all the way in, I'll put it right here because this is kind of where I've got room. So I'm going to put 55 degrees, and just to clarify, that's for the blue angle. And then I'm going to use the color red now for 20. And then I'm going to use the color green now for x. So again, notice that we have one equation. We had to solve for y before we can solve for x. Now I'm going to add 55, which is blue, to red, which is 20, to green, which is x, and all three of those angles inside the triangle have to add up to 180. So here's the equation for that. So I've got 20 plus 55 plus x has to be equal to 180. I will combine 20 and 55, those are constant terms, and I'd like to group something with x, but we only have one x there. So let's see, 20 and 55, that's 75 plus x equals 180. And then to solve for x, I'll subtract 75 on both sides. So that's going to cancel, and I now have x is equal to 180 minus 75, and that gives me 105. And 105, again, notice right here, the question is find the value of x. We found out that x is 105, so I'm just going to box that, and we are good to go. So again, when they ask you to find x, and x is not immediately next to the exterior angle, you'll have two equations. In example number 8, you're going to see why it's going to be super easy. First of all, 159 is the exterior angle. Switching over to blue, the interior angle right next to it is x. So really, notice that the red angle is right next to the blue angle. Mathematically, we call that adjacent. And we understand that when you have a pair of angles that form a straight line, they're called a linear pair. And just like the last example, a linear pair have to add up to 180. So I'm going to go ahead and I'm going to write the blue angle plus the red angle has to be equal to 180 degrees. Then I'll subtract 159 from both sides. Cancels, and now I have x is equal to, let's see, 180 minus 59, that's going to result in 21. And so this 109 degrees, we didn't even really need it to influence what we wanted here for x. So there you go. X equals 21.